Difference between isotropic and anisotropic materials? What isotropic materials? Isotropic materials are materials that have the same physical properties in all directions. In other words, their properties, such as density, strength, and stiffness, are the same regardless of the direction in which they are measured. This means that the material behaves uniformly under loads and deformations, and it does not exhibit any directional dependencies in its properties. Some examples of isotropic materials include metals, plastics, and ceramics. Isotropic materials are often used in engineering applications where uniform behavior is desired, such as in the design of structural elements or machine components. They are also easier to model and analyze than anisotropic materials, which have different properties in different directions. However, isotropic materials may not always be the most suitable choice for certain applications, as they may not exhibit the desired properties or behavior in certain circumstances. What is anisotropic materials? Anisotropic materials are materials that have different physical properties in different directions. In other words, their properties, such as density, strength, and stiffness, are not the same in all directions, and they can vary significantly depending on the orientation of the material. This means that the material behaves differently under loads and deformations depending on the direction in which it is subjected to them. Some examples of anisotropic materials include wood, composites, and some types of metals. Anisotropic materials are often used in engineering applications where specific properties or behavior are desired in certain directions, such as in the design of structural elements or machine components. They can exhibit a range of properties, such as high strength or stiffness in one direction and low strength or stiffness in another direction. However, anisotropic materials can be more challenging to model and analyze than isotropic materials, as their properties depend on the direction in which they are measured. Difference between isotropic and anisotropic materials? One of the main differences between isotropic and anisotropic materials is their mechanical behavior. Isotropic materials have the same mechanical properties in all directions, while anisotropic materials have different mechanical properties in different directions. For example, wood is an anisotropic material that is stronger in the direction of the grain than it is perpendicular to the grain. The difference between isotropic and anisotropic materials is important to consider in engineering applications, as it can affect the way that a material behaves under different loads and conditions. Isotropic materials are often easier to model and predict the behavior of, but anisotropic materials may offer unique properties or advantages in certain applications. Thanks for watching.